Hi everyone, in this video we're going to be talking about something called synthetic division. Now this is really helpful when you are given a polynomial division problem where you're able to guarantee a few conditions, or at least one condition. If you're dividing some polynomial by x minus r, right? So let's say you have, let me move this here. Let's say you have something like a n x to the n plus a n minus 1 x to the n minus 1 plus a1x plus a0, and you're dividing it by x minus r, okay? Then you're able to do something called polynomial long division. Or called a synthetic division. The only requirement here is that you're dividing by x minus r. That is a big requirement here. Okay? So this is very important because that minus r is going to be what you need in order to do this, right? So let's go ahead and see if we can go through the process of synthetic division here. Okay, so for this first example, we have a pretty simple one. X squared minus 3x plus 2 divided by x minus 2. So you could, really with this one, I set this one up very nicely so it should work out nicely. You could just use your standard rational expression, factor it, and then do some division from there. But that's not what we're going to do here. Here we're going to use something called synthetic division. So let's go ahead and set it up. So what you're going to do is you're going to create like a normal looking long division sign here, okay? But instead of putting x squared minus 3x plus 2 on the inside, you're just going to put all of the coefficients, okay? So each coefficient is what you're going to put in here. So we have x squared, so our first term is going to be 1, all right? We have minus 3x, so our next term is going to be minus 3, plus 2, so our last term is going to be 2. And then what we're going to do is we're going to put our r term here. So we're dividing x squared minus 3x plus 2 divided by x minus 2. So x minus 2 is of the form x minus r, where r is some number. So we're going to put 2 out front, okay? We're going to put the r value out front, okay? Not minus 2, we're going to put 2 out front. Okay, and the first thing we're going to do is we're going to draw an arrow here on this one, and we're going to just bring the 1 down. Then we're going to multiply this 2 times 1. Okay, 2 times 1, and that's going to give us 2. And we're going to put that 2 here. Now we're going to add negative 3 and 2. Negative 3 plus 2 is negative 1. And now we're going to multiply negative 1 and 2 again. So negative 1 times 2 is negative 2. So then we have 2 plus negative 2, that is 0. Okay, so now what we're given here, 1 and negative 1, these are the coefficients of a polynomial that is 1 degree lower than the degree of this polynomial. Okay, so we're going to have a degree 1 polynomial. So we're going to have x minus 1. Okay, the 1 goes here. This 1 goes here. And then this term here, this is called the remainder. Okay? So our answer here is going to be x minus 1 with a remainder of 0. All right? So let's try another one. Here we have negative 2x to the third plus 8x squared minus 9x plus 6 divided by x minus 3. So let's set this up in the synthetic division format. So the first thing we do is we make sure we have something of the form x minus r. So if x minus 3, that's good. We're good to go. Okay? So we're going to put 3 right here. And now we're going to put all of our coefficients down. So we'll have negative 2. That comes from the coefficient on the x to the third term. We'll have 8 from the x squared term. We'll have minus 9 from the x term. And we'll have 6 from the constant term. Okay? Draw a line. And we're going to bring down this first term. This first term here is negative 2. So negative 2 times 3 is going to give us negative 6. 8 plus negative 6 is 2. 2 times 3 is going to give us 6. Negative 9 plus 6 is negative 3. Negative 3 times 3 is negative 9. And 6 plus -9 is -3. So now we have the coefficients. These terms here, these numbers here, are the coefficients of a polynomial that is 1 degree lower. Okay? So this is going to be, so we started with a degree 3 polynomial. Now we're going to have a degree 2. So this is going to become -2x squared. I guess we can write this up here. Equals -2x squared plus 2x minus 3. And then we have a remainder here of -3. So we can write this as -3 over x minus 3. Or you can just write remainder -3. That's fine as well. Okay, so again, this -2 goes here. This 2 goes here. The -3 goes here. And then this is your remainder term. Okay, that's how we're doing synthetic division. So hopefully you agree, this is actually pretty neat. It's a lot faster than doing polynomial long division if you're given the right circumstances. Okay, how about this one? Here we have x to the third plus 6x squared minus 8x minus 7 divided by x plus 7. So your first reaction might be to say, oh, all right, well, we're done. We don't have x minus 7, so we can't do anything. But that's actually not true. Okay, so it should be noted that x plus 7 is equal to x minus -7. X minus -7, okay? So that just means that our r value here is going to be -7. So we can set it up as so. So we'll have -7 for our r value, and we'll have 1, 6, -8, and -7. We're going to bring the 1 term down. -7 times 1 gives us -7. 6 plus -7 is -1. -7 times -1 is +7. -8 plus 7 is -1. And -7 times -1 gives us +7. -7 plus 7 gives us 0. So great, we have a remainder of 0. Okay, and that means we're going to have now a polynomial that is 1 degree lower than what we started with. We started with x to the third, so we're going to have a x squared term out front. So we'll have 1x squared, or just x squared, minus 1x, or just x, and then minus 1, with no remainder. Okay, so this would be your answer. Okay, and there's one other thing we need to be very careful about with these. This is huge. This might be the more important thing to remember from this lesson here. Obviously, it's you need to remember the x minus r, so you need to rewrite it that way. But the other thing is that you have to have something in place for every single descending exponent. Okay, so here's what I mean by this. So let's start here. So we have we're having x to the third minus 22x plus 15 divided by x plus 5. Well, we know to start with that x plus 5 is equal to x minus -5. So we know that -5 is our r term. Okay, so let's start putting in our coefficients. So we have 1 for x to the third. But here's where we have to be careful. So you'll notice we have x to the third, and then we go right to the x term. We don't have an x squared term. So since we don't have an x squared term, we're going to put a 0 where the x squared term would go, right? And this is because we have this is equal to x to the third plus 0x squared minus 22x plus 15, okay? So you have to put a 0 in for that, right? So yeah, you have to make sure you include every descending term of your polynomial. Okay, but then we have a minus 22 for our x term and a plus 15 for our constant term. And now we're good to go. So we start by bringing down the 1. We have -5 times 1 is -5. 0 plus -5 is -5. -5 times -5 is positive 25. And -22 plus 25, that's positive 3. -5 times 3 is... -5 times 3 is -15. 15 plus -15 is 0. So we have a remainder of 0. And therefore, our answer is going to be x squared minus 5x plus 3. And again, these coefficients come from here. So this is the x squared term. This is the x term. This is the constant term. Okay, so hopefully you'd agree this is a little bit faster than doing polynomial long division. Polynomial long division will work all of the time. This will not work all of the time, but if you're given a good scenario, this is probably the much faster way to go if you're able to use synthetic division.